Assalamualaikum and hi guys. This is Subtopic 2.2 Quantum Mechanical Model. The first three learning outcome that you are going to learn is describe the term orbital, explain all four quantum numbers of an electron in an orbital, and sketch the 3D shape of the orbitals that we call it as S, P and D with the correct orientations. First, let's look at the orbital. Orbital is a three-dimensional region in space around the nucleus within which there is a high probability of finding an electron within an atom or molecule. This is the orbital yang you nampak yang you buat line yang you buat line bulat-bulat tu kan. Okay, so it's actually a region. Satu kawasan, dia bukan duduk dekat satu line. It's a 3D region, kawasan yang space around the nucleus. Okay, and in this region, there is high probability of finding an electron. Quantum number that I mentioned in the second learning outcome, okay, there are four quantum numbers that you are going to learn. The first one is principal quantum number, N, angular momentum quantum number, L. The other name for this quantum number is azimuthal momentum quantum number, subsidiary momentum quantum number, or orbital quantum number. The third quantum number is magnetic quantum number, and the last quantum number is spin quantum number. Let's learn the first quantum number, which is principal quantum number. This quantum number represents energy and also size of orbital. N is a positive integer until infinity. Okay, for example, N ini sebenarnya merujuk kepada energy level. Okay, if you learn in the subtopic 2.1, you ada belajar energy level, N equal to 1, N equal to 2, and so on. Okay, itulah juga N. Cuma, selain daripada represent the energy level, N ini juga represent kepada size of orbital itu. Contoh, for the electron dekat N equal to 1, okay, size orbital dia is smaller if you compare dengan elektron yang duduk dekat N equal to 2. Okay, orbital dekat N equal to 2, size dia besar sikit, size orbital dia. Okay, compared to the N equal to 1. Dan semakin meningkat nilai N, okay, seperti energy level diagram that you learned before, okay, the higher the energy of that electron has. The second quantum number is angular momentum quantum number, which is L. Okay, this quantum number represent the shape of orbital. Orbital sebenarnya ada macam-macam bentuk, okay, and this shape kita boleh wakilkan dia menggunakan angular momentum quantum number punya nombor. You will get the number of L from the value of N. So daripada N, you akan dapat nilai L. So L is actually integer starting from 0 until N minus 1. Sebab itulah saya mention tadi, to get the value of L, you can refer to the value of N. Before you look at the example, this is the coding. Macam angular momentum number tu, dia macam satu code nombor. So if L itu equal to 0, that's mean orbital itu adalah orbital S, dan bentuk orbital S tu adalah bentuk spherical, untuk bulat. Angular momentum number dia L equal to 1, dia adalah orbital P orbital, dan the shape of P orbital adalah bentuk dumbbell. If L equal to 2, that means the orbital is D orbital with the shape clover leaf. So, bentuk dumbbell macam dumbbell, spherical bentuk bulat kan. Clover leaf, bentuk clover leaf lah, dia ada 4. So, let's look at the example. If you have the N equal to 1, that means L awak equal to 0. Kalau N equal to 2, that means L dia adalah 0, 1. Sebab L is integer starting from 0 until N minus 1. So, memang start dengan 0. Lepas tu, 2 minus 1 is 1. So, sampai 1 saja. Next one. If N equal to 3, what is the number for L? So, the number for L will be 0, 1, and 2. After you dah dapat the code number untuk angular momentum quantum number ini, then you can identify the orbital. For N equal to 1, L equal to 0. L equal to 0 represent orbital S. Okay, so that's mean specifically orbital tu adalah 1s. 1 ni datang dari mana? This number 1 is referring to the N. S is referring to the L equal to 0. So this is how you identify the name of the orbital based on the quantum number. So let's try the second one. What is the orbital if n equal to 2, L equal to 0? So the orbital is 2s. Kalau n equal to 2, L equal to 1, orbital dia adalah 2p. 2 referring to the n, p referring to the L equal to 1. So L equal to 1 is p, simbol dia. Maka orbital dia adalah 2p. The last one, we have 3s, 3p and 3d. Okay, kita tengok n sama dengan berapa, kemudian dia L dia berapa. Each value of L represent different symbol for orbital. So if L equal to 2 is referring to the D punya orbital symbol, maka nama orbital dia adalah orbital 3D. The third quantum number is magnetic quantum number, M. This quantum number determines the orientation of orbital in space. Orientation tu maksudnya tadi you ada belajar sama ada dia bentuk bulat, bentuk dumbbell ataupun bentuk cloverleaf. For example, for p orbital, dumbbell. So dumbbell tu keadaannya macam begini ke, tegak macam ni ke, sengit macam ni ke. That is mean by the orientation of orbital here. It also indicates the maximum number of orbital for a particular value of L. The number of possible M values is 2L plus 1. This one minta akan tunjuk nanti. Okay, M is an integer from negative L through 0 until plus L. That's mean to get the value of M, you must refer to the value of L. Macam tadi, N menentukan nilai L, L menentukan nilai M. Okay, so for example here, if L equal to 0, that's mean M awak, the value of M, it will be 0. If L equal to 1, okay, it say here, M is integer from negative L. That's mean if L equal to 1, so nilai M awak adalah negative 1. Kemudian dia kata through 0, melalui kosong, 0 until plus L. L kita 1 until plus 1. Let's try the last one. L equal to 2. That means the value of M are negative 2, negative 1, 0, plus 1, plus 2. Itu maksud dia. It start from its integer from negative L. Negative L dia negative 2 kan? So L dia 2. So negative 2 through 0 akan lalu 0. Negative 2, negative 1, 0 until plus L. L dia 2, so until plus 2. So after 0, plus 1 and plus 2. This is how you identify the value for magnetic quantum number. This point merujuk kepada number of possible M values. Contoh macam ni, contoh Medang ambil yang 2 ini. Okay. Berapa banyak sepatutnya nilai M yang you ada? Okay. 2 kali L dia sama dengan 2 kan? 2 tambah 1. So sepatutnya you akan ada 5 values of M. So ada 5 tak? Ada 5 lah. 1, 2, 3, 4, 5. It's like how to check whether you have all the values of magnetic quantum number. Itu maksud the third point here. The next slide explaining the second point, which is, okay, the value of magnetic quantum number juga menentukan the number of orbital. Tadi kita tengok L sama dengan 0, nilai M dia 0. Sebab L is the S orbital. Okay, S orbital ada satu jenis. Ni lah, macam ni je cara lukisan S orbital. Tak ada cara lain. Sebab kenapa? Sebab nilai M dia ada satu nilai. Dia ada satu je nilai M. That's why ada satu je cara melukis S orbital. P orbital. So since there are 3 values of M, that means there are 3 ways to draw P orbital. The first point tadi is M is referring to the orientation of that orbital. Okay, orientation maksudnya it also means there are how many ways to draw that orbital. Okay, here P orbital, there are 3 value of M. That means there are 3 ways to draw P orbital. Okay, so P orbital, kita ada Px, Py, Pz.